Hi everyone, in this video we'll be discussing the problem that is 3 numbers which was asked in the contest. The problem says that you'll be given 3 numbers A, B and C, and in one move you can increment any of the numbers A, B or C by 1. What you have to do is you have to find the minimum number of moves after which the parity of all the 3 numbers will be the same, right? So the problem says that they will give you 3 numbers, so they will give you a number A, they will give you a number B and they will give you a number C. And what you have to do is you have to make their parity same. Basically, what does parity mean? Parity means even or odd. If let's talk about some sample test case for this particular question. So if let's say you have been given 4, 1 and 4. If you have been given A, B, C as 4, 1 and 4. So in this particular case, what you can observe is that the 4 is an even number. Then this 4 is an even number as well. And this one is an odd number. So what I can do is I can simply take this number and I can increment it by 1 as it has been mentioned, and I can make it 2. Once I make it 2, so all of them become even. So all of them have the same parity. Parity means that either all of them should be even or all of them should be odd. So in one move I can do that, right? So that's what the question says. Now in this particular question, what you have to do is you'll be given the 3 numbers A, B, C. You have to tell that what is the minimum number of moves that you will take to make the parity of all the 3 numbers as same, right? Let's talk about this case. Like as it has been mentioned in this particular case, you can observe that in one move we can increase the second number, that is 1 to 2, and now the parity of all the 3 numbers will be the same, that is all of them will be even, right? Now in the next case, if I have to talk about the next case, so let's say if all the numbers, like if the numbers has been given 1 1 1, right? So second test case, so in this case you can easily observe that this number is odd, the number 1 is also odd, and the third number is also odd, right? Since all the numbers are odd, so they are having the same parity, so that's why you will not take any moves, and you will do this in 0 number of moves, right? Now let's say that there can be circumstances, right? Let's say if the number is 1 2 3, let's say if the 3 numbers given to you are 1 2 3, so one of them is odd, this one is odd, this one is even, and this one is odd. So if you will observe that, then what you can observe in this particular case, that this particular number is even, right? So this one different, so if you add 1 to it, then you will get the answer. So now the situation is that either the answer will be 0 or the answer would be 1. Why? Because either it can happen that there can be cases that can be there in the question. There can be some of the cases, let's talk about them. So basically what can happen is either the numbers are given as, all the 3 numbers might be given as odd odd odd. In that case you will require 0 moves, right? Otherwise, if let's say the numbers are given as even, all the numbers are even, right? Then what will happen? The moves required will be 0. And another case could be that suppose there are 2 odd numbers and one number is even, right? One of the numbers among ABC is even and other 2 numbers are odd. In that case, you will require how many moves? 1 move only, so that you can change the even number to the odd number. Similarly, if you have 2 even numbers and 1 odd number, so you will take 1 move to change the odd number to the even number, right? So this will also take 1 move. So these can be the circumstances that can lie ahead. So basically what you can do is you can check that if all the numbers are having all the numbers are odd, in that case 0 moves is required. If all the numbers are even, then in that case 0 moves is required. In the other cases, one move each is required. Now you can write it using if case and all those things, but to write a short code, you can easily observe that what you can do is, like if you want to do in the simplest way possible, what you can do is, if you have been given ABC, right? If you have been given ABC, so what you can do is you can check it, you can check with this and this, right? So basically what you can say is, like let's say if you have been given 1 2 and 3, right? So if you have been given this particular thing, so if the parity of 1 and 2 is not the same and the parity of 2 and 3 is not the same, in that case what will happen? I need 1 move, right? So initially the maximum that I need is 1 move. So if the parities are not the same, I will need 1 move, otherwise I'll need 0 moves. Why? Because let's say if you give me numbers like 4 and 8 and let's say 16, right? If you give me these numbers, so I'll check what is the parity of the middle number. The middle number is 8, B is 8, so it is an even number. I'll check it with the left number, that is A. So this number is also even, so both the numbers are same. Now I'll check with the right number and the middle number, this is also same. So if A mod 2 is equal to B mod 2 and it happens that B mod 2 is equal to C mod 2, That means that I'm covering this case as well. That is, let's say 3 and 9 and 11. If this case is existing, so I can check that okay, this is odd and this is odd. Similarly, this middle is odd and this right number is also odd, right? So B and A are also odd and B and C are also odd, right? So that will mean that over all the numbers are having the same parity, that is odd. So basically I need to check that if A mod 2 is equal to B mod 2 and B mod 2 is equal to C mod 2, in that case I will not require any moves. The number of moves required will be 0. Otherwise, initially I can make the number of moves as 1. If this condition is not satisfied, if it happens that the parity of all the three numbers are not the same, so in that case I'll have this answer 1. Otherwise, if the parities are same, then my answer will get updated to 0 and I'll simply return it. Let's check out the code for this particular problem. I'll quickly show it to you. You take T as an input, T test cases. Then what you do is you take ABC as an input. You mark the result as 1, the minimum number of moves as 1. Because if the parities are not the same, then actually you will require maximum 1 move, right? After that, what you do is you check with the middle number B. If A mod 2 is equal to B mod 2, that means if let's say B is odd, then A is also odd. Then you are checking that whether C is odd or not. If that is, if ABC both are ABC all three are odd, that is having the same parity, in that case you will not require any move, so the result will be 0. Otherwise, if ABC or all are even, so their parity would be same again. In that case you will also not require any move, so the result would be marked as 0. In the end, you simply return the answer and that will work. Let me submit this code to show you that it's working fine. So you can see that it got accepted. Thanks a lot for watching. Hi everyone, welcome to the video tutorial of the problem minimum XOR. In this particular problem, you will be given an integer n as an input. So basically you'll be given an integer n as an input. So let's say that n is given to be 3. So let's say if n is given to be 3, so what you have to do is you have to choose an integer x such that x is strictly greater than n. So you have to choose an integer x such that x is strictly greater than n. They have mentioned it here that x can be any integer strictly greater than n. And what you have to do is you have to print the minimum possible value of x XOR n. So you have to print the minimum possible value of x XOR n. Now once you choose a x that is strictly greater than n, you have to print the minimum possible value of x XOR n, right? So x XOR n should be minimum possible. Now before moving forward, let's talk about the properties of XOR. So the first property that will the first thing that you need to know is that if both the bits are 1, if 1 XOR 1 I am doing, so I'll get a 0. If I am doing 1 XOR 0, so I'll get a 1. If I'm doing for the bit 0 XOR 1, so I'll get a 1. If I'm doing for 0 XOR 0, so I'll get a 0. So basically, if both the bits are same, then I'll get a 0, like in this case you can see. And if both the bits are different, in that case I'll get a 1. So this is something that you need to know before starting with this question, right? Now in this particular question, let's say that the value was given to me like this. Let's say you give me n as 3. So what is the representation of 3? 3's representation is nothing but this, right? So if you give me n is equal to 3, now you can say that if I want to choose any x such that x is greater than n, and I need to do x XOR n such that it gives me minimum value, right? So you'll think that maybe you can apply a brute force kind of approach, but brute force is not possible here. Looking at the constraints, you will easily be able to observe that the brute force will not work here. So you need to deal with bits. Now how many bits do you need to deal with? So basically you can see that n value is nothing like 10 to the power 18. So since n value is something close to 10 to the power 18, so in that case the number of if the n value, if the n value is like 10 to the power 9, so the number of bits that are set are usually 33. So you check for 33 bits, right? So similarly, if the n value is 10 to the power 18, so basically you can say that 60 or 62 bits will be set. So that's the maximum that you will check, because in 62 bits, 2 to the power 62, you will be able to get to that particular number 10 to the power 18, right? So that's how much you will check. Now if let's say if the value n is given to you like this, now you need to choose an x such that the XOR is minimum possible, right? So let's observe. So if you have this particular bit as set, so what do you want? You want this to be like, you can say that okay, if this is 1, if this is 1 as well, if this is 1 as well. Now what is this number? If I'll choose x, so x can be 5. So let's suppose that I choose x is equal to 5. I'm dealing with bits, okay? I'm not randomly choosing the number, I'm dealing with bits. So that's why you can say that if this particular bit is 1, this particular bit is 1, and this particular bit is 0, right? So in that case I can mark it as, I can choose nx as 1. Now I'll XOR the value, so I'll get here a 0, I'll get here a 0, and I'll get here what? I'll get a 1. So what is this? What is this? This is nothing but n XOR x, and like XOR n, this value is what? This is the binary representation, and if I'll talk about this, so this is the number 4, and this is the minimum possible value that I'll get. So basically what I've done is I've checked that if the bits are 1, then I've tried to kept them as same, and then like I've started from the left, and whichever bit is not set I've marked as 1. So basically if you are telling me, so if this bit is set, so I've done what? If this particular bit is set, in that case I've marked it as 1. If this particular bit is set, I've kept it as 1. If this particular bit is 0, I need to mark it as 1, and in that case ultimately what I've done is I've got this particular thing. So basically for any number that I have, I'll start from the least significant bit, and I'll check that if that particular bit is set, then I'll mark it as 1, and that will give me the lowest answer. Now let's talk about this particular code. You can easily observe, like if let's say if the test case was like n was given to you as something like 15, then the XOR value that you will get actually is then the minimum value n XOR x that you will get is 16. Now why is that so? Because you can apply this particular concept and you will easily be able to observe that is how you will do it. Because if let's say if you have this thing, so I'll draw the representation. So 1 2 4 and I get 8, so this is 12, this much. Okay, so this much part is there. So this is the representation. Now which number we are getting? We are getting 16, but basically you can see that this is minimum possible that you can get. So let's say if this is 16 that I'm getting, so what representation did I keep? So I kept this particular representation, that is I must have marked this as 1, this is 1, this is 1, this is 1, and this must have been a 0. So I marked it as 1. Now what happens when I XOR it? So when I XOR these values, so you can see that I have chosen a number that is strictly greater than 15. Now the number is strictly greater than 15, and I'm getting this particular XOR value. That's why I'm getting a 16. So that is nothing but 1, 2, 4, 8 and 16. So that's what we are doing. Basically you check from the left, and then you will be able to do it. You check from the least significant bit till the highest bit possible, right? So let's walk through the code. Basically in this what you'll be doing is you'll be choosing long, otherwise you'll get a wrong answer because the values are going to be very large. So you take the n as an input, you iterate for all the 62 bits. I start from 0, I is less than 62, so basically from 0 till the 61 bit, so because the bits are starting from 0. So you check that if the particular ith bit is set in this particular given number, if the ith bit is set, right? So if this particular bit is set, then 1 raised to the power 2 to the power I, this will give me 2 to the power I. So that means I'll mark the ith bit as set. If it is set in this particular value n, so in that case it will give the x value 0, right? Why? Because if let's suppose that I'm coming to this particular bit, let's suppose that I'm talking about a number such that, let's say if I'm talking about this, let's say I'm talking about 1 and 0, right? If I'm talking about 1 and 0, so if this particular bit I'm talking about, right? So I've said that if I'm at this particular bit, so I'll do this particular bit and with this particular bit. So if I'll do 0 and 1, so what I'll get 0, right? So that is something that I need to notice, that if this particular bit was 0 and I mark this as 1, right? So in that case I'll get the answer as 0, and that is minimizing the answer. So that is what I needed to check, that if I'm setting this particular ith bit and I'm doing the AND with it and I'm getting it as 0, in that case that will be the immediate answer. So basically I'll print 2 to the power I as the answer, and that will be the answer. Basically, as I told you in the case of 3, as I told you, like if I have 1 and 1, then what I can do is I can simply say that I come to this bit. Now if I set this particular bit, so what do I get? I get a 0. If I set this particular bit, so I get a 0, right? But is that the highest number that I wanted? No, that's not the number that I wanted. So basically that's how you will be checking it, and in the end you will be able to find the answer. So basically you need to find a x such that it is greater than n, and XOR n is minimum possible. So you need to check in terms of bit, and I've already explained the concept. So this is the code, and thanks a lot for watching. If you have any doubts, you can mention that in the comments and I'll reply them as soon as possible. Thank you. Hi everyone, welcome to the video editorial for this problem that is named as two strings. In this particular problem, what you'll be given is you'll be given two binary strings A and B. So suppose that you have been given two binary strings. The first string is A and the second string is B. Let's say the first string was something like 0 1 and the second string B is 1 0, right? So what you have to do is, in this particular problem, the problem says that you can perform two types of moves. Basically, either you can swap the adjacent in the elements, like in the string A, you can change only the string A, and the string A, in the string A, what you can do is you can choose a particular index I such that it is valid, and you can swap it with the I plus 1th index, right? So that is what you can do. Like in this case, let's say if there was a string 00010 something like this, so what you could have done is you could have chosen this as I and this is I plus 1, and you could have swapped these two indexes, right? So it could have become 00100, right? So that's what they are saying in the first operation. In the second operation, they are saying that you could pick two distinct indices I and j such that ai is equal to aj and flip both the values. So basically, if suppose that the string was something like this, if the suppose the string was 0011001, so in that case what you could have done is, if you wanted to change, so you could have chosen maybe this index and this index, so both of them, this can be I, this can be j, you could have chosen these two indexes and you could have flipped their sign, so this one would have become 0 and this one also would have become 0, right? So these are the two kinds of operations that you can perform on the first string that's been given to you. Now what you have to do is you have to find the minimum number of moves in which you can make the string A equal to string B, if it is possible. It can be possible or it cannot be possible. We'll see test cases for that. So if it's possible to convert A to B, then you have to print the minimum number of moves. Otherwise, you have to print -1. So this is what the question states. Now let's have a look at the sample test cases. So basically, let's say if you have been given this particular string that we initially took, like if you have been given A is equal to, if you have been given A is equal to 0, 1 and B is equal to, if you have been given A as 0, 1 and B is equal to 1, 0, right? So in this particular case, which operation will you perform? You will perform the first operation, first kind of move. That is, what you will do is you will choose this as I and this as I plus 1, and you'll swap these two index, like you will change their positions like this. So it will become 1, 0. So the first string would become equal to the second string B, and in this case you will take one move, right? Now there can be other circumstances as well. Like let's have a look at the test cases. So if let's say 1, 0, like this particular string that's been given to you, as we have seen. So let's say if the string A was given to me as 101. So if the string A was given to me as 101 and the string B was given to me as 110, right? So in this case, as we told, you take this as I and this as I plus 1, you change these two, so that's why it will become 1100. So in one move you can easily do it, right? Now let's have a look at when it will be -1. So there can be circumstances when the answer would be -1. So when will it not be possible for you to do that? So basically, let's suppose that the string A is given and the string B is given. I'll take the sample test cases that have been given to us. So suppose string A is equal to 1, 1, 0 and 1, 1, 1, 0 and 1, and the string B is given as 0, 0, 1, 1, right? So if it is given as 0, 0, 1, 1, so in this case the answer is not possible. But why is that not possible? The reason for that is that if you will count the number of ones and the number of zeros, the parity, if you will check, so here what is happening is, if you will see the actual difference, so the number of ones in the first string is 3, the number of ones in the final string B is 2, so the difference comes out to be 1, right? So the difference is odd. Now let's check for this. So for this, the number of zeros in the first string is 1, the number of zeros in the second string is 2. If I calculate the absolute difference, so the difference comes out to be 1. It could have been 3, 1, 3 or something like that. Basically, if the difference comes out to be odd, then that means it is not possible. Why? Because in that case, how will you swap it? Like let's talk about this particular case. So if you are saying that okay, this particular string is there, so what you can do is, if you are having 1, 1, 0 and 1, and if you want to convert it to 0, 0, 1, 1, right? So you can tell me that okay, I'll choose this index and this index, do different indexes, and you can swap these, flip these. So if you will flip these two, so it will become what? It will become, instead of 1, 1, it will become 0, 0. Now what the final string is? Final string is 0, 0, 1, 1. Now you can easily observe that final string is this, and you have this particular string, right? So you have this particular segment that is not equal still. Like this particular segment is equal, but this particular 0 is not equal. Now if you just have one element, so how will you equate it? Either zeros will not match or ones will not match. So that will be the condition that will occur if the number of zeros or the number of ones are odd. If either of them is odd, then in that the difference is odd, then in that case it will not be possible, because you can see that this character, the first, second and the fourth character are equal, but the third character is not equal, even though we applied the operations optimally. So in that case, basically you need to check that if the difference of zeros and the ones, if any of them is odd, then in that case you will say that the answer is not possible, right? Now let's see when the answer is possible, then what will be the situations. So let's suppose that this is a particular case that we have 0 0 0 and 1, and we have another case as 1 0 0 0, right? So you will, when you see this particular string A and B, now you'll directly tell me that okay, this particular string, this particular character, you just bring it here, right? So you will say that in 3 steps I can do that, right? I bring to this, then this, then this, right? So in 3 steps I can bring it to the adjacent one, right? That is something that I can do. Okay, now next up, what I can do is 3 the minimum number of operations that I can do? No, that's not the answer. Why? Because I could have done another thing. What I could have done is, I have this particular string, right? The original string A, that is 0 0 0 and 1. What I could have done is, I could choose this index and this index, and I swap them. That is applying the second kind of move. So I make this as 1 1. Now what's the situation? The situation is that now this looks like this. Now in this particular case, what I can observe is, I want to make it as 1 0 0 0, right? So what I can do is, I can simply say that I can choose this particular index and this particular index, right? So up till now I've taken one move. Now in the second move, what I can do is, I can choose this index and this index. So basically I can choose an I and I can choose an J, and what I can do is, I can flip the signs. So if I'll flip the signs, so this will look like 1 0 0 0. Now you can see that the string, initial string was given to me like this, then I converted it to this in one move, and in the second move I converted it to this. So in 2 moves I was able to do it. So the number of operations that I was requiring was 2, right? Now let's talk about another case. Maybe we might have left it. So let's say if it was 0 0 0 0 and the final string that you wanted was 1 0 0 1. So if you wanted B as 1 0 0 1 and A was given to you as this, so basically you can do it in one move. Why? Because you can choose this particular index and this particular index, and you can change it to 1, right? So that's why it will be done in one move only. So another thing that you need to notice in this particular case is that if the count of, you also need to notice the count of zeros and the count of ones. So if I'll say that the count of zeros is existing, like if there is count of zeros and if there is count of ones, right, and I need to do that. So basically let's talk about this particular case. So let's say it was 0 0 0 0 and the final string was 1 0 0 1, right? So if I'll tell you about this particular case, so let's talk about this case. So let's see, this 0, these are the places where I'm not equal, right? So basically the answer is what? The answer, I have 2 zeros that are not equal, but the answer is what? If I have 2 zeros that are not at the same and I want to convert them to 1, so basically the count, whatever the count of zeros I'm having, I'll divide it by 2 and I'll get the answer for that. Similar will be the case for this one. So basically the count of zeros divided by 2 will give me the answer for the zeros, and count of ones divided by 2 will give me the answers for ones. Now the operations will depend, like the final operations plus I'll be adding an operation. Operation can either be 0, 1 or 2, that will depend on the case, as I have already told you. So let's check out the code for this particular problem. I have explained all the edge cases for this particular problem. Now let's check out the code quickly. So what you will be doing is, you will be taking t as an input. Then what you will be doing is, you take the string length as an input, you take the first and the second string as an input, you mark a counter C for the counter of C0 means that you will be counting for zeros, C1 means you will be counting for ones. Basically you iterate through the very first string, that is A, and what you do is, if a particular character is present, like if there is a 0 present or there is a 1 present, so you add its frequency, then you iterate through the second string and you subtract the corresponding frequency for the character. Now if either A or B is 0, right, if either the character 0 or the character 1 is present odd number of times, in that case I have already told you that the answer would be -1, because it will not be possible, because if the character is present odd number of times, in that case you cannot do the changes. Now otherwise what you'll do is, as I told you, the maximum number of operations that you'll require is not 3 but 2, right? As I already told you, like you will take a dummy index and then you can swap it. I already told you that why operations will take 2 instead of 3 if the strings are, if suppose that kind of situation occurs. So basically you'll iterate through this string, and if a of I is equal to b of I, if both the characters are same, then in that case you will directly move. Otherwise you will increase the frequency of the current character that's not equal. So basically you will make a new map because this map is exhausted. So you'll make a basically a new frequency counting. You will count the frequency of the character that's not equal. Now you will check that if I plus 1 is lesser than n, so you'll check that if a of I is not equal to b of I plus 1. So if the ith character is not the same for both the strings, and I plus 1th character is also not the same, and I plus 1th character is not equal to the ith character of I, so that means I can take one operation and I can do it, right? So basically what does this mean? So basically this indicates the case where suppose the string is like this. If the string that I want is 1 0, I finally want, let's say, 1 0, and if I have a as 0 1, right? So in this case I can see that the ith character is not same, I plus 1th is not the same. So in that case the number of operations that I'll require is 1. Why? The additional operation that I'll require is 1 because I can directly swap it, right? So that's what I'll require. So that's why I've marked operations as 1. Initially the maximum operations that I can take is 2, as I've already told you. Now I'll check if c of 0 is if the count of zeros that I have, and if it's and 1, if this condition comes out to be true, then I'll check for the false. If this is false, then in that case the number of operations that I'll require is 0, right? I've already told you in the test cases. Now in the end what you need to do is, you already have stored the operations, you already have the operations with you, and I already told you that you have to do this, that the frequency of zeros that you have divided by 2 plus the frequency of ones that you have divided by 2, because half of the chances you will take, like in the half frequency you will be able to do the job for each 0 and each 1, right? That is different. And then you add the number of operations additionally that will be required. So that's the video tutorial for this particular problem. In case if you have any doubt, you can mention that in the comments and I'll reply at them as soon as possible. Thank you.
So here we have problem GCD game. So let's talk about what the problem is about. So in this problem, you will be given an undirected tree and there will be two players, A and B, which will be placed at random nodes initially, right? Now they will start playing a game in which they can move to their adjacent nodes, like it can move here, then it can move here, right? And B can also do the same. And they will move alternatively, like firstly A will move, then B will move, then A, and so on, right? Now the score of A will be equal to GCD of all the nodes that are visited by A, right? So the score of A will be GCD of all the nodes that are visited by A. And after moving to a particular node, like let's suppose the value of these nodes are 2, 1, 3, 4, 5, and so on for the other nodes, right? So if move A moves to this place, then it will assign 0 to this node, right? And similarly, if B moves from here to here, it will assign 0 to this node, right? And since A was initially here, so it will also be 0 and this will become 0, right? So after moving at particular node, they will assign 0 to that node, right? And A will try to maximize its score and B will try to minimize the score of A, right? And the game will end when both A and B will not be having any choice to move, right? Let's suppose if A moves from here to here, then it will reach here, and from here it cannot go anywhere because it can go here, but this node is already visited, so it will not go here, right? So A will not be able to move. Similarly, if B moves here at the leaf node, then it will not be able to move anywhere, right? So both A and B will be reaching at a leaf node to end the game, right? So that was the first conclusion. So what are the possible ways for B? So the B can move away from A or it can move towards A, right? So if it's moved towards A, then there will be a path that will be joining A and B, right? And in this path, there will be a mid node, right? So this is the middle node for this path, right? Now A will be able to move here before than B because A is moving firstly, so it will move on this node, B will move on this node, and A will reach here. So A will reach here quickly than B, right? And now whatever the path which is followed by B, A will also follow that path, right? Let's suppose B reaches here and it will go here, then here. So it will assign 0 to these nodes, right? And now for A, this will be the optimal path because if you have some list of numbers 2, 4, 6, like you have this list of number and you can add so many zeros as you want, it will not affect the GCD of this list, right? On the other case, if you let's suppose add 5, so initially the GCD of this list was 2, and now it will become, after adding 5, it will become 1, right? So the conclusion is that you will not be adding much values to your list, right? So A will try to minimize the number of nodes that he can add into its list, right? So A will follow the path of B because the nodes will be 0 and it will be beneficial for A to choose those paths, right? Similarly, let's take another case. So let's suppose um, if B is moving on this path, right? So all these nodes will be 0, right? So if A moves up till here, then rather than following this path, it will follow this path, right? Because this path will not affect the GCD of A, right? While this path can decrease the score of A by decreasing the GCD, right? So A will always follow the path of B. So what you can do in this scenario, you can find the what will be the maximum score of A. So it can be the score of this path. So either he can take this path or he can take this path, right? Or he can take this path. But if A comes up till here, then he will surely take this path, right? And the score of A will always be equal to this path, right? Up till this path. Okay, because this path will not affect the GCD of A. So whatever the score of A will be equal to only this path, right? So that's what we are going to do. We'll firstly explore whatever the paths that B can explore before A, right? So this is the path that is connecting B to A. Now this node and this node will be visited by B before A, right? So we can either consider up till this one or we can consider up till this one. Then A will be coming up till this or up till this, right? Or it can move here also, or it can choose this path also. So from these four paths, we can find whatever the maximum score that A can get, right? So that will be the answer. So let's look into the code. So here we have T number of test cases. So in main, we have declared T and we are running while loop, like it will be for T test cases. So now we are calling this function and we are taking n as an input. So this will be the number of nodes that are present in the tree. And after that, we are just taking the number of that node for each node, right? And this is G. So this is our graph. We are clearing our graph, and then for this is a parent array. So for every node, initially we are defining 0 as the parent of that node, right? Now we will be taking input of the edges, right? So these two nodes will be connected by an edge. So here we are making adjacency list. And after that, we are taking the values of A and B. So these are the two players, right? So now, as I have discussed, this DFS1 function will create the path from A to B, right? So this is our DFS function in which we will pass A and 0. So what this function will do, let me tell you. So in this tree, we will be traversing from A and will be creating a path from A to B, right? So the parent of A will be this node. So let's number these nodes. So let's say this is 1, this is 2, this is 3, this is 4, and this is 5. So parent of 1 will be 2, right? So, and parent of 2 will be 3, parent of 3 will be 4, and parent of 4 will be 5, right? So it will be like this. So a path will be created from A to B, right? So that's what this code is doing, right? It is creating a path. Now, once we have created the path, we will find what is the last node that is visited by B before A, right? So in this case, this will be the last node which can be visited by B before A, right? So whatever the length of this path, we will divide it by 2 and we will get the last node, right? So now we will traverse in these nodes as I have discussed before. So we will traverse from this node and it will go to this node, right? So for all the nodes, we will be checking if that particular node is a leaf node or it is having a branch, right? So in this case, this is having a branch, right? So either we can follow this path, like it can go here, right? Or it can follow the, let's suppose if this was the leaf node, then also we can go up till here only, right? So A will come here and follow this path, right? So that's what we are doing here. We are marking that node as the node. So that will be the node that is reached by B before A, right? So now after coming here, we will be finding whatever the answer, the possible answer for A, right? So we'll be calling this function DFS2. Okay. So in this DFS2 function, we will be considering all the possibilities of A. So let's suppose B has moved up till here. Now, what are the possibilities of A? So either A can go up till here, or it can go up till here, or it can go up till here, right? Right. So we are uh, we are doing DFS from A until we have reached a leaf node, or until we have reached a node which is traversed by B, right? So that's what we are doing in this function. So like we are calculating GCD of each node until we have reached a leaf node. So this is the condition for leaf node, or the node is equal to NO, which is the node which was traversed by B, right? So like this will be the NO, and these are the leaf node. So three possibilities will be there: this one, and this one. And we will be considering all these possibilities for A, and we will be finding whatever the maximum of these three possibilities, right? So we are calculating maximum here. Now we will move here, right? So here we are calculating minimum of all those answers, right? So why we are calculating minimum? So B will either move from here to here, or it will move here, right? So whatever the minimum value that A can get, on the basis of that B will choose its moves, right? So either B can move here or here by minimizing the answer of A. So that's why we are taking the minimum of those answers, right? So now there will be the last possibility if B moves towards like B moves in the path of A, right? So let's suppose A was moving here and B also moves in the path of A, right? Now now A will have to choose some different path, right? It cannot move on the same path of B, right? Because it has already moved on that path. So A will be moving on this path, or it can move on this path, or it can move on this path, or it can move on this path or this path, right? So what we will do, we will just place 0 on all the positions that can be traced by B before A, and then we will be considering whole tree, and we will be doing DFS from A to find out what are the possible ways that A can explore. Like I have told you earlier, what are the ways that A can explore. So here we are marking all the values to 0 that are explored by B, and we will be marking the number as -1, right? Because now we are not bothering about the uh, place up till where B has moved, right? Because A will not be following the path of B, right? So now I'll be calculating again the answer of A, and whatever the minimum of those answers that will be returned, right? So here the same function will run and it will calculate all the possible answers for A, and it will return the maximum of those possible answers, right? So that was all about this problem. So I hope you have understood this problem, and yeah, so thank you.
Hi, let us discuss the question. So, an array is called good if all the elements are greater than is equals to 0. That is, the elements are non-negative. Okay, non-negative. The next is for any pair I and j such that it is not the same index. Okay, so the current element with all other elements. This is, it shouldn't be with that element only. The element A of I and A of j does not belong in the array A. Here and denotes the bitwise AND operation. Okay, so it is told that all the elements would be non-negative, and for any pair means, for suppose for the first element, if it makes some pair with the second, third, fourth till last, it goes on. That is how it is. Given an integer n, Utkarsh is interested in finding a good array A of length n such that the maximum value we have in the array is minimized. Okay, Utkarsh does not need the whole array, but rather he just wants the maximum element. So before talking about minimizing the maximum element, what we can talk is what are the good arrays. Okay, what are the good arrays we can find. To find the good arrays, suppose the value is 2. What we can do is we can have 1 and then 1 0. So the only available pair are these two elements, and the AND of these two elements is 0, which is not present. This, so 1 and 10 is nothing but 1 and 2. This is the binary representation. Okay, now let us talk about minimizing this. If we want to minimize this, okay, then we can have 0 and 1. If we have 0 and 1, then the AND of both is 0, which is present. Then we can't have it. Then it can be 1 and 2. Yes, it can be. So we can see that for the value 2, the minimum value is 2. Okay. Now let's talk about the sample cases. So the number of test cases, this tells us that how many cases we need to handle. Then moving forward, we have 1. So if the value is 1, there is no pair to consider. If there is no pair to consider, we assign it the smallest value that we have. What is the smallest non-negative value that we have? We have 0. We can see that. Now let's come to the 3. So the first value can be 1, the next value can be 1, 0, and the next value can be 1, 0, 0. And the AND of this with this is 0, AND of this with this is 0, AND of this with this is 0. But 0 is not present, and this is the binary representation. So representing it in decimal would be 1, 2, and 4. So the maximum value that we have is 4. Then we have 4. Now the same thing would continue, but this value would change and this thing would be there. Okay, again, and the value of this is 8. So the maximum value we have is 8. Okay, this is the minimum maximum value. Now, whenever we see a bit problem, the first thing that we should do is we should analyze in terms of bit. Okay, in terms of bit representation. Why in terms of bit representation? Because the number of bits in a particular number is feasible enough to be acted as a constant. Like for 10 to the power 9, the maximum upper limit would be 10 to the power 32, and it is most probably sufficient for everyone. And 10 to the power 32 and 32 operations would be acted as a constant if the values are in values of the array or something. The value in the ranges range from 1 to 10 to the power 5. It would act as a constant. So what we can do is we can, if it is a constant value, the best part would be to try all possible, okay, all possible ways, and then we find the minimum. Okay, the idea of dynamic programming, but not likely dynamic programming, you can think of it as use the application of recursion. Okay, now, what we can do is we need to first find out how many possible combination exist. Okay, how many possible combination exist. To do that, we would just use the value n choose r. Okay, we would use this combination value. Now to find out this combination value n choose r, what we would be doing here is we would be using Fermat's little theorem. Okay, Fermat's little theorem to compute the values and to answer each query efficiently. Okay, now you can read about this Fermat little theorem because it is expected that you already know Fermat's little theorem to find efficiently and choose R. Okay, then you can move forward. You can pause the video at this time. Now we are moving forward. Suppose we find out the combinations. Then if the combination boils down to the value 0, then we would be saying that yes, this is the value. If it is 1, if the value is 1, then we can assign it any value. So this would act as a base case. Okay. So let us have a look at the code. Then you would be having a proper understanding how we would be finding all the possible combination and selecting the minimum out of it by using recursion. Okay. So now what we are doing here is we are first having a mod value declared as a constant. Then we have the n value to store the factorial inverse. Okay. Now the computation of factorial of NCR is done by Fermat's little theorem. We are finding the factors, we are finding the inverse of it. And then in this we are taking the input n, and if n is equals to 1, we would take the smallest non-negative value and we would return from that point, that is 0. Then we would take care of the test cases. Okay, factorial computation is done at the beginning because the factorial computation won't change. Now moving forward, we would have all the test cases. In this function solve, we would take the input n, then we would have this recurse. Okay, we are going till 100 because then we can say that it is the upper limit. Still we are again catering if n is equals to 0. Okay, moving forward, we are having alpha is equals to 1, so you can just replace the alpha with I. Okay, but alpha looks a more suitable value than this. So now if the current value is greater than the size of we desire, what we would do is we would have the limit, we would subtract the value of NCR, and then we would first take out the current value. So by using the current value and by iterating over all the bits, we would have the current value and assign it over that. So basically this is just that if that particular value is turned on, we add that value of 2 to the power 2. So 1 0 0, what is this? This is just 2 to the power 2. Okay, 0 1 2. This is how we are adding the values at this point. Then we are recursing for the rest of the cases. Now at this point, after recursing, if the value becomes 0, then we are returning that say yes, this is the current value. Else we are taking out the maximum of current value, and this we are turning on the bits that is left and we are returning the answer. Okay, so main task here was to think recursively and to use Fermat's little theorem, okay, to answer NCR efficiently. So that's it for today. If you face any difficulties in implementation or if you want my help, just consider tagging me and asking me the doubts. Okay, thank you and have a nice day.